All right, expected value of random variables. We can answer all sorts of important questions when we're analyzing this. Here's one. There's a spinner. Clearly, every spot on this spinner is equally likely, has just as much area. It may look like this space is bigger, but it's probably just an optical illusion. There's nothing wrong with my drawing. But if this is your spinner and every place along that circle has an equally likely chance of being landed upon, then this is our probability distribution. The random variable takes on the values that can be spun. Notice that 5 happens twice in 2 of the 5 spaces. That's 40%. The other probabilities are 1 out of 5. There's the expected value formula for a random variable. It's at the top of the page on your formula sheet for probabilities. If we use it, the expected value of x is each value of x times its corresponding probability and add them all up, and we get 19. If you use a calculator, you can do list 1, list 2, put your variable of interest in here, which would be all the values the random variable takes on. So literally, this would be list 1 right here, and in list 2, you'll put all the probabilities, and then you go stat, go to one of our stats, list 1, list 2, and boop, it'll spit out for you your expected value and even your standard deviation and other things. Now in addition, this might be, if this was a game at a casino in Vegas, then if you were expected to make $19 per spin, guess what? They're going to charge you $20 so that they make $1 for every 20 times that you spin, so you lose 5%. And let that be a lesson to you. Vegas is fun. They want you to have fun losing money. All right, so it's exciting and you can lose money. There's other ways to be excited and lose money. You could go down an alleyway in New York City during the middle of the night and you'd probably find excitement and get mugged and lose your money there too. But casinos, probably a more interesting way to have that happen. Here, let's look at another expected value situation. Let's look at a real life situation where it's business and how much money do we expect to make, or how many things do we expect to sell. Let's say we're getting into turtle ranching. It's all a ploy to get kids hooked at a young age to get into ranching so we can revive that industry. So we're going to start out with turtles. Big old snap turtles. Okay, we got turtles in a pen, big ones. All right, so then remember the mean average. This would be x would be the number of turtles sold in a day. So number of turtles sold in a day by a salesperson. So the average number of turtles, that should be an x. The average number of turtles sold would be found by taking the number of turtles times their corresponding probabilities. We add that up, we get 1.2. So on average, every salesperson should expect to sell at least, or on average, 1.2 turtles per day. I don't know what 0.2 of a turtle looks like. But if we have a regular mean, if we just added the 0 plus the 1 plus the 2 plus the 3, just added those values up and divided by 4, we wouldn't get the right expected value. We wouldn't get the right mean average because every one of those values would carry an equal weight here. By paying attention to the weightings and the likelihoods, that's why we multiply each outcome by the corresponding probability, and that's why the mean average is pulled to the left of what otherwise would be the mean average, because the most likely scenario is selling 1, not 1.5 or 2 or whatever. So now, if a salesperson earns $15 in commission per total sold, then what is his or her expected pay? Well, unfortunately, to do that, all we do is we say, well, we can now take 15 times the random variable. You could literally multiply each of these values by 15 and recalculate, but we know that all we have to do is take our mean average, number of turtles sold, multiply it by the fact that we're getting $15 per total, and they're making about $18 per day. Really sad. I mean, the salesperson's not making much money. Hey, if you're desperate, maybe you could go to work down the street for the plant factory, but you'd be working for peanuts if that were the case. And then one more thing, we might have a customer reward program where people say, hey, buy 3 turtles, we'll get you a book, like a book on psychology, because you got to be nuts to be a turtle rancher. But knowing that most of their customer base is less than 10 years old, maybe we could just throw in a bag of Jolly Ranchers, all right? Then the kids would be happy. They'd be happy campers and Jolly Ranchers. Turtles, it's good. One last thing, if we look at this from a binomial standpoint, it really is important for us to realize the random variable when it comes to binomial is keeping track of the number of successes. And so we could literally make a probability distribution for this discrete random variable. It can only take on values from 0 through 5, because it can have anywhere from 0 through 5 successes. And then when we get down here, we realize, oh, the probability that x could take on any one of these, like what's the probability we get 2 successes? Hey, that's the binomial probability formula that goes right there. If we want to use the calculator, it's binomial PDF. If we want to answer the question, what's the probability we get at least 1 success out of 5, well then you realize this is what we're after, all these probabilities added together. But the quickest way to do that, knowing that all 6 scenarios from 0 through 5 successes would add up to a probability of 1, the quickest thing we can do whenever we see this idea of at least 1 success, we find the probability of getting no successes, and we do 1 minus the probability of 0 successes. That can be calculated very easily. If a success is 0.3, then we take 0.7 to the 5th power, we do 1 minus that. So anyway, this is how random variables tie together, what they represent, and how to find the expected value or the mean average.